In the previous video, we learnt about intersection of two or three sets. Today, we are going to learn about disjoint sets. What are disjoint sets? If the intersection of set A and set B is an empty set, then the set A and set B are disjoint sets. Means if the intersection of two sets is an empty set, that means there is no common element between. If there is no common element between any two sets, then those sets are called as disjoint sets. For example, suppose if I take set A is equal to as 1, 2, 3 and so on up to 10. Set B is equal to as 15, 16, 17 up to 25. The intersection of set A and B is an empty set. There is no common element at all. So when there is no common element, then we can say that therefore set A and set B, set A and set B are disjoint sets. Disjoint sets. So any two or three sets, if they do not have any common elements, or the intersection of the sets is an empty set, then the sets is called as a disjoint sets. Now we are going to learn about union of sets. Union of sets. Now, for example, if I take this, suppose set A is given example. Set B is equal to as then A union symbol is just U. A union B contains all the elements 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20 up to 25. It is a set which includes all the elements of set A and B. So, union of set means union of set is a set containing all the elements of set A and set B. So it contains A union B contains the elements of set A and set B. Children, now see, we can write A union B in the builder form in this way. X is an element such that X belongs to A or X belongs to B. For intersection, we write what? X is an element such that X belongs to A and X belongs to B. But when we write or X belongs to set A or X belongs to set B, it is union of A union B. In the Venn diagram, we write it in this form. Now, in the builder form, we write it in this form. Now, this is a Venn diagram. You have to write the sets, different sets. Now, universal set. What is the universal set here? See the smallest number here. Which is the smallest number? 18, 19, 20, 21, 22 and so on, and the 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. That means The elements of the universal set starts from 18 to 40. So universal set 18, 19, 20. No need to write all the elements up to it is 40. This is a universal set. Now set A 21, 22, 23 up to the biggest number is 30. So 21, 22 and so on up to 30. Set B. The smallest one here in this circle B is 27. Start from 27, 28 and so on up to 36. Now, A union B. Altogether, A union B, 21, 22 up to 36. It is 21, 22, 23 and so on up to 36. This is A union B. A intersection B is the common elements between A and B. That is 27, 28, 27, 28, 29, 30. A intersection B. A complement. Complement of A, that is you leave the elements of set A, rest all which is in there in the universal set. So 21, 18 is not there in set A, 18, 19, 20, then 21 to 30 it is in set A, we have to leave off, then 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. This is complement of A. Then B complement. Leave off the elements of set B. Rest all elements which are outside the circle B. So it starts from again 18, 19, 20, 21 up to 26. 19, 20, 21, 22, 23, 24, 25, 26. Then 27 to 36 is in set B. Then 30. After 26 you have to write 37, 38, 39, then 40. This is complement of B. So from the Venn diagram we have got the universal set, set A, set B, A union B, A intersection B, A complement, B complement. Then we can write A union B complement. A union B complement. A union B is 21 to 36. Rest all this, the elements which is there outside the circle is A union B complement. So it is 18, 19, 20, 37, 38, 39, 40. This is A union B complement. Now, A intersection B complement. A intersection B is only this 27, 28, 29, 30. These four elements you have to leave, rest all you have to take, that is A intersection B complement. So it starts from 18, 19, instead of writing all this, I will write up to 26, then 27 to 30 it is not there, 31. It starts, next element is 31, 32 and so on up to 40. This is A intersection B complement. So in this way from the given diagram we can write all the sets. Now let us learn properties of a union of sets. First property, A union B is equal to B union A. Let us understand it by example. Suppose I take set A, 1, 2, set A. Then set B is equal to as, suppose this is set B. Now A union B you find out. A union B. A union B is equal to as. We have to take all the elements of set A and B. 1, 2, 3, 4, 5, 6, 7 up to 8. This is A union B. Now, this is only in B union A. B union A. Take all the elements of B and A. In the arranged form, again it will be 1, 2, 3 and so on up to 8. So from this point 1 and point 2, we understand that we can see that A union B is equal to B union A. So from 1 and 2, it is understood A union B is equal to B union A. Union is written as simple U. Just see the difference, and this is the universal in this way. Now, if A is subset of B, then A union B is equal to set B. A is subset of B means all the elements of A is present in set B. So we will take such example. Now set A, if I take 13, 14, 15. This is set A. Now set B. B is equal to, suppose, set B I have taken 10 to 20. Set A is equal to as 11 to 50. Now set A, all the elements is present in set B. That means A is subset of B. Then what is A union B? Now let us find out what is A union B. A union B starts from 10, 11, 12 and so on up to 20. You have to take all the elements of set A and set B, that is A union B. Now if you observe set B 10 to 20, set A union B is again 10 to 20. So if A is subset of B, then A union B is equal to set B. Therefore A union B, if A is subset of B, then A union B is equal to set B. If it is in this form, if suppose B is subset of A, then again A union B will be equal. If B is subset of A, then A union B is equal to set A in this form. Now, let us go to the next property. A is subset of A union B. A is subset of A union B and B is also subset of A union B always. With this example also we can see. With the first example, set A and set B. Look at set A, look at set B. A is subset of A union B. Now A union B contains 1 to 8. So you can see set A and set A union B. All the elements of set A is present in A union B. Yes. So A is subset of, always A is subset of A union B. Then look at this. All the elements of set B is also present in set A union B. So B is subset of A union B. So with the example 1 in property 1, or we can take different example also. Suppose I take example as set A is 51, 52, 53 and so on up to 60. Then set B is equal to as 5, 56, 57 and so on up to 70. Now what is A union B? A union B starts from 51, 52, 53 and so on up to 70. A union B contains all the elements of set A and set B. So here we can see that A is all the elements of set A is present in A union B. All the elements of set B is present in A union B. Therefore, we can say that A is subset of always A is subset of A union B, and set B is also always subset of A union B. Come to fourth property. A union complement of A is always equal to a universal set. So for this, to explain with the example, I have to take a universal set. Suppose if I take universal set from 1 to up to 20. Set A, if I take it as set of even numbers 2, 4, 6, 8 and so on up to 20. So what is complement of A? Let us find out complement of A. When A is set of all even numbers, then set of all odd numbers in the universal set will be complement of A. So 1, 3, 5, 7, 9 and so on up to 90. 9, 11, 13, then 15, 17, 19. This is complement of A. Now what we have to prove? A union A complement. Set A union A complement. These two sets union we have to find out. A union A complement. So take the elements of all this and this set. So here in the arranged form 1, 2 is here, 3 is here, 4 is here, 5 and so on, we'll get it up to 20. So from this, now look at this and look at the universal set. Universal set, let us take it as 1. Then A union complement of A, let us take it as 0.2. So therefore from 1 and 2, it is understood that A union A complement is equal to the universal set, or B union B complement is equal to the universal set. C union complement of C is equal to universal set. D union complement of D is always equal to universal set. Now, fifth property, A union A. A union A set A union itself is equal to set A itself. If I take set A, one to 10, itself with itself union, it is A union A. Same with the same union you have to do with the same set 1, 2, 3, it will be the same. So therefore we can say A union set A is equal to set A itself, or V union B is equal to B. C union C is equal to set C. So this was fifth property. Now sixth property. A union empty set is equal to set A. Example. Set A if I take, suppose 5, 6, 7, 8, 9, 10. Set A. Another set B if I take, set B is an empty set. Elements, there's no elements. So what is A union B? Here, A union B is equal to as 5, 6, 7, 8, 9, 10. We get the same thing. So it is understood that A union B is equal to, now here A union B, I have got, see, set A 5 to 10. This is point 1 you take, this point 2. From 1 and 2 we understood, from point 1 and 2 it is understood that A union B is equal to here, is equal to set A, but set B is an empty set. Therefore, A union empty set is equal to set A. So, A union set, any set, suppose set B union empty set is equal to B. Set C union empty set is equal to set C. Set D union empty set is equal to set D. So, these are the properties of the union of sets.